There is a population of 1,397 people. 299 individuals had big eyes, which is represented by the genotype AA and portrayed by the blue shirt figure. 699 people had normal eyes, which is represented by the genotype AB and portrayed by the green figure. 399 people had small eyes, which is represented by the genotype BB and portrayed by the pink figure. I found the genotype frequencies by dividing the number of people with a certain genotype by the total population. I found the allele frequency by dividing the number of alleles by 2 times the population. To check mathematically that the initial population is in Hardy-Weinberg equilibrium, I found the expected genotype frequency by using the formula to find P and Q, and then plugging those values into the Hardy-Weinberg equation. I then multiplied this by the total population to find the expected number of individuals. Next, I set up a chi-square with a hypothesis that the population of people has Hardy-Weinberg proportion for the eye-sized locus. After filling out the chi-square, I found that my chi value is 0.0475, which is less than the critical value of 3.841. Therefore, I failed to reject the hypothesis. This means that the initial population has Hardy-Weinberg proportions. However, there's a huge rainstorm, and it creates a massive lake in the middle of the population's habitat. At night, it is hard for those with small eyes to see the lake, and it's a little hard for those with normal eyes to see the lake as well. This causes these individuals to fall into the lake and drown. However, individuals with big eyes can see the lake perfectly and do not fall in. This results in directional selection, with small eyes dying off the fastest, normal eyes slowly dying off, and big-eyed people all surviving to mate. In future generations, if the selection continues, then eventually there will only be big-eyed people left. To find the frequency after selection, I multiplied the initial frequency by the fitness and got the unadjusted survivor. Then I divided unadjusted survivor by the average fitness to get the frequency of each genotype after selection. To find the A allele frequency, I added the genotypic frequency for AA and 1/2 of the AB genotypic frequency. To find the B allele frequency, I added the genotypic frequency for BB and 1/2 of the AB genotypic frequency. As you can see, the genotypic ratio for AA has increased, AB slightly increased, and BB decreased from the initial population to generation 1. The A allele frequency increased and the B allele frequency decreased from the initial population to generation 1. This shows that generation 1 is not in Hardy-Weinberg equilibrium and is experiencing directional selection. Thank you.